Okay, so what we've got here are compound inequalities that are the OR type, meaning that when we finally graph them, we will have a split graph. Okay, so we're going to solve these each in turn. We're going to first take the 2x minus 2 is less than negative 12. And we're undoing what's happening to x, so we say plus 2 plus 2. 2x is less than negative 10. Be careful with your integers, positives and negatives. And then dividing by 2, which is the coefficient of the variable, we've got x is less than negative 5. That's one portion of this. Okay? And then we've got this OR situation that says OR 2x plus 3 is greater than 7. And again, solving this, we say that subtract 3, 2x is greater than 4, and dividing both sides by 2. We've got x is greater than 2. Okay? So x can either be greater than 2 or it can be less than negative 5. And I'm going to draw a number line because I don't have one installed into this at the moment. Okay, so we say boom. Okay, I like to go at least one further than the number that we're graphing, so I'm going to call that negative 6, negative 5. And I'm only going to label every fifth one, so that's negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, oops, 2, 3, 4, 5, 6, and 7. Okay? And we've got an endpoint at negative 5. We've got an endpoint at 2. Now, can we be equal to negative 5? No, it does not say or equals here. Okay, so we leave it open. We leave this open. Can it be equal to 2? No, can't be equal to 2 because it doesn't say or equals, so we leave it open. Now, which side do we shade on? Well, this says x is less than negative 5. Less than negative 5 is going this way. And as we said, we have that split inequality. Or here, we've got x is greater than 2. And it can't be equal to 2, but it can be greater than 2. So all numbers that are greater than 2, like this. And that is our graphed inequality. It is split, and you can see it's split because of this OR part of the problem. Okay, one. All right, what are the solutions of the compound inequality? We're going to graph when we finally get it. And I'm going to do this in parts. So I'm taking this 2x minus 1 over 3 plus 3 is less than or equal to negative 4. I'm going to solve this first. Okay, and the first thing I'm going to do is undo this plus 3 with a minus 3. So minus 3, minus 3. And we've got 2x minus 1 over 3 is less than or equal to negative 7. Okay, now I have to undo this divided by 3. And I do that with a times 3. So 3 parentheses, everything that's already on that side, 2x minus 1 over 3, is less than or equal to 3 parentheses, everything that's already on that side, negative 7. Okay, this cancels out. So you've just got 2x minus 1 is less than or equal to negative 21. And we add 1, add 1. And we've got 2x is less than or equal to negative 20. And dividing both sides by 2, we've got x is less than or equal to negative 10. Okay, so that is, oops, one half of this, sorry, and now let's do the other half. We take the other side. It says or here, so we're going to have a split inequality, right? And we do 8x minus 2 over 2 minus 1 greater than or equal to 6. And I'm going to undo this minus 1 with a plus 1. That's the first thing I'm going to do. Plus 1, and we get 8x minus 2 over 2 is greater than or equal to 7. And now I'm going to multiply both sides by 2. 2 parentheses, everything that's there, 8x minus 2 over 2 is greater than or equal to 2 parentheses, everything that's there, 7. Okay, this cancels out, giving 8x minus 2 is greater than or equal to 2 times 7 is 14. Now I say plus 2, and we get 8x is greater than or equal to 16. And we say 8x divided by 8 is greater than or equal to 16 divided by 8, or x is greater than or equal to 2. So this is the second part. Okay, I'm going to do a number line down here. And you see that there's a number down at negative 10. I'm going to do this one this way. I'm going to say this is negative 10, and this is 2. I'm just going to write it like that. Okay, normally I don't want you to write that, but they're pretty far apart. That's fine. Okay, so let's go down here to negative 10. We're going to put an endpoint at negative 10. Can it be or equals? Yeah, it says or equals, so we can fill this endpoint in. Okay, I'm going to go up here to 2. Put an endpoint. Can we fill it in? Yeah, this says or equals here, so we can fill it in. Okay, now going back here to the negative 10, x is less than or equal to that negative 10. We're going to take values that are less than that endpoint there, so it's going to look like that. And up here, this says x is greater than or equal to 2. So that endpoint 2, we're talking about values greater than that. That's how you graph it, and that's done. So really, you're treating this a lot like solving an equation. And one trick that didn't come up in these two slides, but you have to keep in mind is that if at any point you multiply or divide by a negative, you would flip this direction of the inequality. But we didn't. We multiplied here by a positive 3, so it doesn't flip, right? We divided here by a positive 2, so it doesn't flip. Same thing over on the right-hand side. Multiplied by a positive number, don't change anything, right? Divided by a positive number, you don't change anything. But you've always got to remember that that's a possibility. Okay? Hope that helps.